Vans did a nice job a couple weeks ago, whenever that was, of their update. And so I thought that we should do the same thing. Similar problems that we've all faced in all industries. So that, and we're going to answer some customers' questions. We have a customer that sent in quite a few questions that we're kind of going to go through that. And then we invite you to in the chat box to type in your questions, and we'll get through as many of those as we can. So we're trying to focus mostly on new builder questions, but we'll take anything. So let's get started off with the Cleveland tool update. We've made quite a few changes over the last couple of years. One of the first things that we've done is to our website, and kind of developed a new user experience that way. Bill, do you want to talk about that at all? Kind of putting you on the spot, but
no, it's all right. Yeah, we spent well, Mike and I collectively probably spent 6 years trying to figure out what web solution would be the right one for the customers, and ended up landing on Shopify. With Jency's help, we mapped out an updated customer experience, especially around kit buying, and spent probably a good solid year putting together the landing page for those kits, and making sure that buying experience was as seamless as possible. We have definitely, after 22 years on the previous software that we were on, there were definitely some transition changes or challenges that we had to overcome, but definitely have found a much better experience, I think, from a management experience, helping us serve you better, and also hopefully allowing you to have a much better experience buying on the website.
And it is a great experience from my perspective anyway, as a pretend customer going in and looking at it. And I know that we've been in business for almost 30 years now. Actually, 30 years ago, we started developing our Dimple dies. I'm going to back up and just give a little history for some new guys that aren't familiar with the last 30 years of Cleveland Aircraft Tool. So we started making Dimple dies in 1992, and my father Buzz had RV4 that he won grand champion at at Oshkosh with, and so Cleveland kind of started out of that. People would call and say, "How did you get your skins to be that flat?" Well, I made a Dimple die, or I made a tool or whatever. So he decided that we should probably produce these dies and make them available to other builders that wanted to do high quality work like that. He was a amateur machinist, built clocks and steam engines and stuff. So really had a great attention to detail. So we started making Dimple dies. We originally started trying to find other people to make Dimple dies, and we just couldn't find anybody that would hold the quality standards that we insisted upon. And so we ended up buying a lathe, and he knew how to run a lathe, and I knew how to run a computer, and we argued back and forth for a year, and finally ended up with the Dimple dies that we sell today, same design 30 years later. So we started making Dimple dies in 92, but then in 93 kind of added the other things, because customers would call to get good Dimple dies and say, well, where can I get a good squeezer? Where can I get a good rivet gun? Because at the time, we were all buying stuff from competitors that sold inferior tools. And so you ended up with 3 sets of everything trying to find a good one. So that's kind of the short story of how Cleveland got in business. And Greg from Vans was on with me 6 months ago, right before Oshkosh, and he asked a question: how did Cleveland get the name? And I completely forgot to answer it during the webcast, so I'll do that now. So the Cleveland is a family name, and so when we started it, Jency was young. My dad, DJ, my stepmom, and I started the tool business, and we didn't figure anybody could spell Lauritsen or pronounce it or probably remember it. And my grandfather had started an ice cream store and named it Ripley's Dairy after my grandmother's maiden name. So DJ's maiden name was Cleveland, and that's how we named Cleveland Aircraft Tool. Cleveland is spelled different. Some people notice it's CLEA. That's the way the family name is spelled. And so that's the story behind how we got named Cleveland. We're in Boone, Iowa, always have been. Let's see, what else? So back in the late 90s, I started coding a website in HTML, text only. Then we added some pictures. Then we got some better pictures as the web developed. And Bill kind of married into this, and I think probably unknowingly got roped into it. And then, of course, Jency, as she went through college and was working here, she got involved in the business too. And she's taken us great places in the last couple of years. So Jen's kind of give an overview of some of the changes we've changed in our product line and why it was important for us to do this for the customer experience.
Yeah, in the last few years, obviously bringing us onto Shopify hopefully streamlined the kit customization process. And as part of that consideration, we also wanted to be sure that what we were including in our kits was still best we could find, the best we could manage to sell ourselves, whether it was producing it ourselves, manufacturing ourselves, or sourcing and then reselling. So what you find in our kits at this point really drives home the commitment that we have as builders ourselves to you all, which is, by builders for builders, and that's kind of who we are. So the things that we think you need, the things that make the quality difference, nice, Mike, that's what we try to include in our kit. And along the way, we've gone ahead and made some cuts, things we no longer include in the kit. And frankly, in almost all of those cases, it's because we know you can find it at a local hardware store at a better price than we can afford to sell it to you at. So things like metal rulers and snips, they're just things that you can get locally, and we love the idea of supporting local business in our build process and hope that you all do too. It's a family value for us for sure. So that's one reason you've seen our product line get even more focused, our kits be a little more specific. We really just want to be sure that what we're putting in the kits is the things we want to be using ourselves and think we can get to reasonably. Yep.
And the reason for the kind of the immediate change, if anybody has noticed that, is because we were just overwhelmed. As Vans has grown, we've grown as well, but our space hasn't grown and our staff hasn't grown. And so we needed a way to manage that. And that's why that whole, well, let's get this group of tools locally kind of concept came in, and that's worked well for us. So let's talk about back orders and squeezers. We've again 30 years, we've hardly had any wait times for anything. I mean, we know that when you're calling us, you've just ordered your kit usually, and we want to get that stuff to you so you can use it, so you can, the last thing you want to do is have an airplane kit that you can't start building. And this last 2 years has changed that paradigm for sure. So we've had internal struggles with production of the stuff that we make in-house. We've had struggles with our suppliers, like everybody. We've had trouble getting materials. It's just been crazy. All of our squeezers are US made. So we have all the parts for our hand squeezers made at a shop here in Iowa, just north of us, maybe 50 miles or so. And they've had trouble getting people to getting bodies in front of the machines. They've told us, we have machines, we have them set up, they're ready to go. We just got to get people in here to run them. And so they're having that trouble. And we hear that story in cross markets and, in everywhere. Our pneumatic squeezers, we've used the same vendor since we started, Atlantic Air Tool in Taft, Tennessee. They make tools primarily for the big aircraft companies. And then when they get squeezers that they shine these up so that they look like they're chrome polished. But when they get them with little pits in them, we get those because we can sell them to you guys for hundreds, maybe $1,000 cheaper than they get from the other guys. So it's works the same quality tool. Again, we've sold them for forever, and they're just super So they've had the same labor problems. We can't get materials. We can't get these back from our vendors who, tumble the castings. So we're kind of getting ahead of that. We've let them know that we're placing these large orders consistently, not just once, and they can, adjust accordingly to meet that demand. We had to switch anodizers for our squeezers, and we had a little trouble with that this last couple of weeks. Got parts in that weren't sealed correctly, so we ended up sealing some here and adding a lot of labor to them that we don't normally do. Normally, we can take them from the anodizer and start building them. So it took about a week to get those done. And correct me if I'm wrong, gents. I think all of our back ordered hand squeezers are going out this week, right?
I believe so. If you have one
I know
on
it's
order.
not your responsibility, but I think you have the latest information.
Yep, I think that we're prepared to be shipping those out. I believe the first half of our back order buildup has gone out yesterday and today, and I believe the rest will be out by end of day tomorrow. So
Yep.
My fingers are crossed. I'll knock on this desk for everybody.
Yeah. And so I forgot about C-frames. We've had the same problem with C-frames that we build here in house. So it's just one of those things that it's like, it's tough knowing that everybody's waiting for them and can't start their kits. So we apologize for that. We're trying to get ahead of it. We're trying to find multiple sources for the same things so that we can have backups.
Yep, that's another great reason that we've kind of pulled the focus of the business back in on where it started, which is, providing the highest quality tools and really just what you can't get elsewhere.
Yep.
So that's
Yep.
the closer we focus, the easier it is to manage these problems that come up.
Because you can get snips at the hardware store. You can't get one of these at the hardware store, right? So the tools that make the difference. So I think that's the only updates that I wanted to give. Did you have anything else?
No, I was just saying I'm watching the chat here on Bill's screen and questions are popping in, and I think our guest John might be here in the mix somewhere as well. So we can shift gears.
I see John on the stripe on top. So yeah, let's go ahead and get to him. So John's a new builder. He's going to build a 14. I believe he's ordered it, but not received it yet. He had a couple questions for me last week, I believe. And I said, hey, will you be a guest on our web stream? And we can get your questions answered there. So welcome, John. And
Thank
everyone
you.
else.
Thank you. It's good to be here. I appreciate you taking my questions.
Yeah. So where do you want to start?
Well, I guess I'll expand a little bit on when you say new builder, I don't have my kit yet. Hoping to get the tail cone, empennage and tail cone kit sometime in this quarter. As you mentioned, vans have some backlogs themselves.
Yep.
But I got the RV 14 toolkit from you it's been about a month ago.
Mm-hmm.
And have been happily setting that up in a friend's shop. And then I've been playing around with the Vans toolbox. So I've been testing out the tools
Right.
and then making mistakes along the way and figuring out what mistake it was I made. So most of the questions I have actually are around riveting, because that seemed to be the thing that was most daunting to me, at least. I've done a lot of woodworking, built some fiberglass kayaks, so I've got got some building experience, but never with metal. So most of the questions I had are around riveting.
And I will mention too that one of the reasons that we're doing this is a lot of new builders have the same questions. So whatever questions you have, I guarantee there's other people listening that have the same questions. So and kind of back to our website redesign, that's one of our focuses on that was different people want different things, and we customize kits because of that. So we kind of build our website around this is kind of what you need, and then you can go through and add and subtract to that to get exactly what you want. So, but we know that that's a pretty steep learning curve in trying to figure out what you want right at the beginning without the experience.
Yeah.
So you had a question about rivet sets and why we recommend the mushroom set. Is that
Yeah,
what I recall? Okay.
yeah, because I saw some EAA videos where they had different kinds they were using. I wanted to
Yeah.
get your opinion.
Yep. So, and again, in my opinion, because a lot of people will disagree with the not wanting to use the swivel mushroom set. So let me switch cameras here and can show you the two side by side. So this set with the rubber guard, the reason it has the big rubber guard is because it swivels. So you don't have to be exactly 90 degrees to the work. And there's the advantage of that is that you can then focus on the bucking bar. I have one here. Talk with my hands. So you can focus on the bucking bar and kind of not pay as much attention to the rivet gun side. And then that's where, the error in the alignment will be. But anytime you have any kind of misalignment, you have a vector of that force that's trying to go that direction and slide the set. So the rubber guard is on there to keep it from sliding. But you can see here that there's quite a lip of rubber. And so when you put try and see if you can see this here. When you put that up against your material, what happens is you have to press so hard to collapse that rubber that you're really pushing too hard on the material. We like the standard mushroom set because you can just hold it up against the work and it's only touching in one little spot there in the center of the mushroom shape. That way you can put it on here. The bucking bar can go on the back side, and then you can set that rivet without really pushing on the part at all. The rivet gun and bucking bar do the work. Now, because you can't focus on the bar, little parts, big tools, sorry. Because you can't focus on the bar and the set at the same time, we always recommend that you have somebody running the rivet gun and somebody else running the bucking bar. If you think about the length of time it takes to get a part ready to rivet versus the length of time it takes to rivet it, most of your work is not riveting. Super experienced builder can chime in on the chat, but what, maybe 5% of the time you spend actually setting rivets, the rest of it's prep for that. So anyway, if you can just wait to set those rivets until you have somebody around to run the bucking bar or run the rivet gun, that's ideal. Now, this will still slide around, and the way we combat that is to capture it with your thumb and index finger. I just don't have the right stuff to be able to show that, but so you hold one hand on the set and the other hand on the rivet gun. And by pressing the thumb and index finger up against the material, it doesn't want to walk around. You're capturing it there, so it doesn't walk around. Doing the same thing as the rubber. Okay, so that's why we like this better. Now, going back to the rubber and what some people do to overcome the shortcomings of it, a lot of people will take a razor blade and trim off, or I've even heard of people using a sander to grind down the rubber so that there's less of it. And you can get that closer to up against the skin, but you can't get rid of it all or it would just slide sideways. But that's something that almost everybody that uses the set says you have to do is cut some of this rubber off around here. So those are, I guess, the reasons. Is there any other specific questions you have about that?
No, that actually answers my question. I just was wondering what you thought of it. The other thing I heard was that it could prevent you from leaving a smile on your sheeting. But it sounds like the way you're talking about holding it with your fingers. Yeah. I have a question about that. So I'd be concerned about pounding my finger.
Sure, sure. Well, I'll tell you what, if you squeeze too hard and you get the meat of your fingers underneath that set, between the set and the skin, you're going to feel it. You're going to adjust quickly.
Okay.
Yeah, definitely. You don't want to get in there. But as far as holding on to the set, yeah, you need to do that. And even with back riveting, I have a long back rivet set here as an example, but it would be the same with a short back rivet set. So here you want to capture that set when you're back riveting, so that the pin can move up and down freely, but you definitely don't want to grab it where the pin is, because that'll bite you too. But it's as long as you're not in line with that force, you're pretty safe with the rivet gun that way. As far as the smile goes, the reason that you're going to get that smile is if it's at an angle. And so that's I can't stress that enough, that your brain can adjust while that rivet gun's hitting, however many times that is. Each time and if you've done some riveting with the bucking bar, you've already experienced this. Each time it moves, you're adjusting it. You just can't do that with both sides. I can't do that with both sides. Maybe some people can, but again, that's the reason for my opinion. So, and I do the same thing with the bucking bar. I'll take the 3 fingers, thumb and index and middle finger, and use that kind of like a tripod up against the back, because the tail of the rivet is on the bar. And then those 3 fingers can kind of make sure that's straight. And as the rivet is setting, you feel it move, and you're adjusting that angle and location.
Gotcha.
So you're not sliding sideways and smearing it.
Right. Okay.
And again, if you get your fingers under between the bar and the skin, you'll feel it and just move out of the way.
Okay, great. I had a bunch of other kind of maybe esoteric questions about rivets, but there were things that I was thinking about.
I did see in your email, you had a question about the skin denting around the rivet. The rivet was good, but the skin was dented around it. Is that how I understood that?
Standard head. Yeah, with the standard head rivet, not a flush head.
So while we're talking about this riveting stuff, let's talk about that as well. So and it doesn't, standard universal head or flush head, it doesn't matter. What's happening there is let me back up a second. So when you're doing this riveting operation, you want the set up against the skin or against the rivet in that case, the bar up against the tail, and as little more pressure as you can get away with. You want the gun and the bar to do the work. So if you get that deformation, it's probably because you're really pushing on the rivet gun. And that's not what's setting the rivet. The impact and the mass is setting the rivet. The other thing that can do that is if you have too small of a bar, too light of a bar, for the size of rivet that you're doing. If you have a really lightweight bar and a heavy rivet, then it can, go that way as well. Okay. So same the other direction. If you have a heavy bar, you could end up pushing the rivet could sit slightly proud on you.
Okay. And can you adjust that with not just the weight of the bar, but the direction, like the tungsten bar that you have in your kit? If you hold it sideways, is that going to give you less force on the back?
Probably somewhat, yeah. Okay. I know that it's harder to set the rivet, same size rivet sideways than if you have the mass in line with it, but
yeah,
theoretically all the mass is still there. So it seems harder if you're trying to do a bar on edge anyway.
Yeah. Okay. Great.
Let's talk about adjusting the rivet gun real quick. That is a question I had from another new builder that was, and I brought a couple things to demonstrate here. See if I can get the right camera angle for that. So had a couple questions actually in the last week about this. The rivet gun, we always recommend airflow restrictor on the base of the gun. So we're controlling the air as it comes in here. It's 90 PSI, and then we're slowing the flow of the air down. And we do that with this airflow restrictor. It's not a regulator, it's a flow restrictor. And it's a needle valve in there. So it takes about 6 or 8 full turns to go from completely off to completely on. So it's a pretty fine adjustment. And you can go just a couple clicks, will go from one size rivet to the next size rivet. So the way to adjust that, and I tried to figure out a way to show this live, but I didn't figure out a way. But essentially put it up against a 2x4 on the floor and pull the trigger and listen to it and adjust it until it sounds right. Try it on a rivet and then go back and adjust again. And once you get that figured out, then for the rivet that you're using, then you can just go up and down a couple clicks for the other rivet. Now, the way the others work that aren't the needle valve type are really designed to be more of an on-off, and they're just a hole. Let's see if I can show that. They're just a hole inside of the valve there, and that hole restricts the flow. So that works somewhat, but you can see that it's a pretty fine adjustment between where you want it, because probably like for the size of rivets that we work with, it's probably almost closed like that. So it just is a very light adjustment to get it to go a long ways. And that's why the needle valve will get you a pretty fine adjustment. So I just wanted to kind of explain that. There are numbers on the side of there, but that's just for reference. It doesn't equate to anything. It's just so that you know that if you were at a 5 for the rivets you were working on and needed to change it for a longer rivet through some extra pieces, then you can go back to the 5 when you're done. So I thought that was a good time to explain that. What's next on your list?
Next on my list was using the rivet, the gauge that comes in the kit as well to check to see how good the shop side of the rivet is. Mm-hmm. So maybe splitting hairs here, but how is it better to be slightly small on the diameter and slightly tall on the height, or slightly big and slightly short on the height? Or
sure. And that's a good question. And again, it's a question lots of people ask. So let me go through first and explain how our rivet gauge works. So the center ones here, for those that haven't used this or haven't seen it before, the center sections are to measure the rivet length before it's set. So a -3 rivet should be this length from the bottom to this shelf here. And if it's that's the ideal length. If it's slightly shorter than that or slightly longer than that, that's usually the case. It's going to be one way or the other. Longer rivets tend to fold over very easily, and so error slightly on the side of the short rivet is usually your best way to go. And then the holes in here are the ideal diameter for the tail once it's set. And then the notches in the corner are the ideal height once it's set. So you have 1.5 times the diameter in width and half the diameter in height. Is that right? Does that sound right? For some reason, I'm drawing a blank. I think that's right. So I just have a rivet sitting here. This is a bad example because it's not dimpled and such, but so you would measure the center here. Oops, I'm not on the screen. So you measure the length of it here before you set it. And then after you set it, you would measure the tail with the hole and the notch. I guess I have a piece here that is done. And so here I can go, it will not quite go through the hole, but angle maybe. And then the height from the bottom of the dimple to the end of the rivet is right on. So that's what I would call ideal, where it won't go through the hole and it's the right height. More often than not, you have it that just barely goes through the hole, like that one. Just barely goes through the hole, but you don't have a lot of side play. And then is the correct height. So you'll find if you're using the rivets called out in the kit, that that's what you generally get. You generally get a rivet that's slightly short when you measure it ahead of time this direction, and just ever so slightly small in the diameter. But again, this is nominal diameter. It's not a tolerance thing where it has to be bigger than this hole. But to kind of balance, and that's what your question is, which way do you go? Do you make it fatter or do you make it shorter? And I just kind of balance those two so that you get as close as you can on diameter and still have it thick enough to be a good rivet. Does that answer your question?
Yeah, it does. And I was concerned about, how also, when is it far enough off that I should think about drilling it out and replacing it?
Almost never.
Yeah. Okay.
You almost always will not get as good of a rivet as that first one. The only time I would advise any different is if you did a whole row of them like that. And you just really shouldn't be doing that. You should be checking, as you go and adjusting as you go. And you'll have a couple that you hit an extra time or two and they'll be a little thin, and then the next ones will be better. I think you're allowed 1 in every 8 to be bad, if I remember correctly. And anybody can jump in the chat if I don't have some of these things right, but that's how I remember it off the top of my head anyway.
Mike, there's a couple of clarifying questions on the rivet gauge.
Okay. Hold on just a second. Let me finish this thought. So
Sure.
You were asking when you would drill it out. One of the times I would probably always drill it out. And this is not for structural reasons, but it's for aesthetics reasons, is if for some reason it sits high. And you feel that rivet edge on top. Because it's pretty hard to correct that. If you can't, so occasionally you can use something with a hole in it on the backside for the tail to go in and then hit it with your flush set and get it to kind of come down. But most of the time that's going to have to come out and get redone to be, acceptable aesthetically. But yeah, usually it's just 1 in a row and just leave it alone because it gets worse if you drill it out.
Right.
And you need to, you'll need to drill some out. So you need to just practice that and get good at it. But yeah, it's fairly easy to correct anyway. So.
Great.
Go ahead, Bill.
Can you confirm, somebody's asking if the corner isn't supposed to measure the minimum height versus it being a half height of, or sorry, I'm getting it wrong. Trying to do the maths. So remind me what the corner is supposed to measure of the rivet gauge?
The corner measures from the bottom of the dimple to the end of the rivet, or sorry, I'm on the wrong rivet. Bottom of the dimple to the end of the rivet, or if it's a non-dimpled rivet, it would be from the skin to the end of the rivet. And it's a square notch, so it's the same either direction.
Got it.
It's that nominal length. So that's the ideal length. It will be just a hair longer than that or a hair shorter than that. You won't hit it right on every single time.
Yep. And then another clarifying question: will you measure the height from the edge of the dimple or the surface of the piece?
And again, if it's dimpled, you measure it from the dimple.
Yeah.
If it's a universal head rivet, or something that's not dimpled on the backside, I guess it could be dimpled in a thick piece. But if it's flat on the backside, you measure from the skin. So you're measuring the head or the tail, technically, of the rivet.
Okay, thanks.
Just the rivet.
That's all.
Okay, John, you're up again.
Okay. So the other question I had was on the toolbox as I was starting on one section and riveting a hinge onto the toolbox. Started on one end and we were doing we were back riveting, so we didn't have clecos in. And by the time we got like 5 rivets in, the next rivet would go through the hole and it would lean to the side.
Yep.
So that we had something going on with the piece.
Yeah, cumulative error there. And anytime you can get multiple clecos in there to hold everything in alignment, that's obviously the best way to do it. But yeah, going, starting a couple from the end, each end, doing one in the middle and working your way back and forth is the way to avoid that.
Okay. For both back riveting and with a bucking bar.
Yep. Well, yeah, it really depends on what you're doing. Sometimes you just have to work your way out. But yeah, anytime you can keep splitting that, you don't chase it one direction that way.
Yeah. Okay. Let me see. The other one, it's kind of a question of trying to get that perfect shop head. How many times can you hit it before you start to get it work hardened? Do you want to try and do it all in one go, like one trigger pull, or does it matter if you do multiple trigger pulls on the rivet gun?
You'll set it further each time. It starts to work harden immediately the first time you hit it, but you can continue to correct it, so to speak. What I've always taught people to do in the classes that we taught was to do like a 1 second trigger pull, like think of a 2-syllable word, aircraft, I don't know, whatever you want, is about 1 second long. The trigger in the gun has a spool valve, and a good gun has a spool valve that will ramp up and ramp down. So as you pull that trigger, the first couple hits are not as intense as when it's full blast. So you end up with this bell shape as you pull the trigger on and off. If you can get that trigger pull down so that it's 1 second or whatever you land on, so that your trigger pull is exactly the same each time, that does a couple of things. First of all, you can adjust your regulator, your airflow restrictor at the base of the gun so that it's correct for that rivet. And then every single time you pull the trigger, that same burst length, you're getting the same number of blows out of the gun. You're hitting it the same number of times. And it helps your bucker know exactly what to expect. If you have somebody holding the bucking bar that thinks you're done and you decide you need to hit it just a second time, that either takes a whole lot of communication or you hit it without the bucking bar on the backside, which is not good. So anyway, that if you can get that 1 second trigger pull down and then adjust your gun to deal with what you're hitting, that's the best thing to do. Now, when you go, especially if you have a 3X gun and you're doing some of the really long 1/8" rivets, you're going to have to turn it up full blast and drive it longer than that. But for the most part, most of the rivets in the airplane are the shorter, smaller ones, and you can get by with that, turning it down and using a given burst length.
Okay. Yeah, that sounds great. Because I was experimenting with different approaches and usually ended up driving too hard, getting too small a shop head or too big a shop.
And I would say that's the direction that most people do, right? They think it needs to be hit harder than it does. Yeah. Okay. So that's, again, your practice on your toolbox, and stuff is pretty valuable that way.
Hey, Mike, do you mind if we pepper in a couple of questions from the chat here?
Nope, go ahead.
So first one I've got is somebody asking about their RV10 kit and having the hardest time deciding what needs to be deburred and what it doesn't need to be deburred.
Next. No, that's I would guess I would call that a personal decision anymore. Vans has a lot of history. They'll tell you that they have a lot of history now of people doing different things, and they're not finding that everything has to be deburred perfectly or the thing falls out of the sky. It's a personal preference. We know that the way we've done it for 30 years in making the edges all smooth and not having any stress concentrations in places to crack works. We also know that that's not how aircraft industry builds airplanes. So it's kind of a personal decision in where you want to go. And I think that some people overdo it on deburring and thin down the edges too much and actually cause more harm than good. And then I'm sure there's some people that put it together without touching it. So I wouldn't be on either spectrum of that. I think that the 3M wheel makes really good work, or does really good work and makes kind of light work out of it. I tell everybody that's your best friend in the shop, because you can just zip them along there, and it's kind of tedious, but it makes pretty light work out of it. And then the areas that are tough, especially with the new tabbed type construction, is the areas down in the corners where it's hard to get anything in and get those. Those kind of things, I just run a piece of Scotch-Brite through and call that good. Some people get pretty detailed on those things, and I don't think there's a right or wrong answer. It's just a personal preference.
Okay. And this is kind of a big question, probably another personal preference, but how important is it to have a drill press to assemble an RB-14A with quick build wings and fuselage?
That's specific. That's awesome.
Yeah, Jency just said you've never not had a drill press, so it's hard to say.
Yeah, it sometimes things are hard for me too, because it's like, which squeezer do I want to use, or which rivet gun do I want to use? Yeah, that's off the top of my head. You have parts in the tail and in the tail cone that you're making that it's handy to have a drill press. You would do it on a drill press if you had it. Whether you need it, probably not. I can't think of an example of where you would need it. In the wings, your control surfaces are all done. The control surfaces on this was a 10, right?
14.
Oh, 14. Okay. So the control surfaces you'll have to do on the tail of that. And they have the trailing edge extrusions. So that's a solid piece of aluminum. I don't know how far you are into this, but I'll just explain it. So it's a solid piece of aluminum on the trailing edge that has to be countersunk to meet the dimples that are on the skins. And so if you had a drill press, that would certainly be the way to do it. If you didn't, clamping that extrusion to a table and doing it with a hand drill would be another acceptable way to do it. So
awesome.
Just depends on where you want to go. You'll use it if you have it. I guarantee that.
And if somebody's looking for approval from the Ways and Means Committee, you have the vote of this panel to go ahead and buy the drill press. Last one before we switch back to John here. How do I know how fast my air drill is turning? I understand the thicker material, the slower you want it, but I don't know how much to adjust the air pressure. And I know we've talked about air pressure regulator a little bit.
Yeah,
regulator.
That's a good question. So I used to tell people, if you look in the machinist handbook, I suppose now if you look on Google, you'd see the speeds and feeds for any given turning tool, any given size of drill bit. So as you were saying, the surface feet that is on the outside edge of that drill bit needs to be the same. So as you get smaller, you have to turn it faster. I think it's like 14,000 RPM on a 3/32 drill. You can't turn it fast enough. So The only time you're going to be slowing that down is when you get into maybe the 1/4 inch, 3/8. I could Google it and see what the recommended speed would be for that. But I would personally, what I would do if you get into those bigger hole sizes is just go to a cordless electric drill and use that. Because first of all, it's few and far between. And second of all, they just turn slower. But as far as how fast you're going, full blast on the small holes, and then you get bigger holes and go into either just kind of guess at a half speed or less, or go to an electric drill, and then you'll be fine. It's all about the chips. If you look at the chips and you have nice chips coming off of it, your feed, how hard you're pressing, and your speed is correct. If you have big chunky chips, you're pushing too hard. If you have lightweight dust coming off of there, you're probably not pushing quite hard enough to engage the tool. So it's a combination of the speed and feed.
Okay, cool. Back to John.
Okay, I had a question about the trailing edges. I was looking through the van's instructions on how to rivet the trailing edges, and it looks daunting.
Everybody's scared of that, and I don't know if I guess it was on Facebook. We had a contest a couple weeks ago and about showing us your benchtop toolbox, something like that, work area. Anyway, one of the things I saw was somebody has a control surface there and it's like ready to go. Said, go ahead and do the next step. It's daunting to everybody, that's for sure. I thought I had one of those control surface sections around here. Let me look around the corner real quick. I don't appear to. So the way the guys at the local Builders Assistance Center do it, and I like that method, is they screw an angle to the edge of the table so that the angle is sticking out from the edge of the table. And then they clamp that down to that edge, and they'll use it like a back rivet plate. Drive the rivet, just like in the manual says, is to do it straight on, and then articulate so that you're parallel with the skin,
right?
Or your gun's perpendicular to the skin. So if you're doing it with a rivet set, that would be the way to do it. We also have a pair of squeezer dies that is made for that. Let me switch cameras here.
That's what those are for.
That's what these are for. And so Bob Avery came up with one to do, let's see, this is the one to do the 14 trailing edge where, oh, I thought it was in the camera, sorry, where it's backwards from the other, well, let's see, 14 elevator trailing edges backwards from the rest of the trailing edge wedges. So it's thicker on the aft end. The others are all thicker on the forward end. So this is the 14 elevator. So the others are backwards from this, the angle's backwards, but the concept is the same. So you can start with a normal straight set of squeezers, just like you would start your rivet gun straight on with the rivet. You can start with a normal set of squeezers, flat squeezer sets, and squeeze the rivet partially, and then come back with these angled squeezer sets and finish squeezing that rivet. A couple different ways to do it. There's pros and cons to both. I think we have a video on that shows using this tool on our YouTube channel. If you want to check that out. But there's some people that really dislike this and like the rivet gun side. I think the squeezer is always more controllable than the rivet gun. So that's always my suggestion.
Hey, Mike, is that blue one actually for the 679 and the red one is for the 14?
Did I get that backwards?
I think so.
You're right. I got it backwards. It's the way I'm looking at it, I guess. So obviously the control surface is, where are we? The control surface is away from the closed edge of the tool. So yes, it comes to a point back here. So you're right. This is for all of the other trailing edges, and the one that's backwards from this is for the 14 elevator. Thank you for clarifying that, Bill.
Yep, no worries.
And just one more point of clarification on using that. You start out with the flat dies, and then move to that to finish the rivet.
Correct, because you're still wanting to start with the sets so that it's starting to collapse that rivet. And really what you're doing is you're filling up that hole that you've made as it's, poofing out. So you're starting to collapse that rivet straight on, and you're setting that bottom, the flush head that's in the dimple. You're setting that so it's not going to move anymore. Then you can go to the angled one to bring that tail down into the other dimple.
Gotcha. That makes me feel much better about tackling that.
And you've been talking about practicing on the toolbox. That's something that you can practice on too. Do a couple of them and get comfortable with it before you start doing the actual. So.
Yeah.
We have about about 8 minutes left. I have about 6 questions from the group, and I'm going to try to make sure that they haven't been answered already. But John, was there anything burning that you had that you wanted to get in front of Mike while we have the time?
No, we made it through all my burning questions. So thank you very much. This was really instructive. Appreciate it.
Well, you'll have more tomorrow.
Yeah, and Stefan made a really good point that the Van's wing section practice kit is also great for practicing that trailing edge wedge. Good point. Thanks for bringing that up, Stefan. Jonathan has a question. Sure. What direction should the adjustable ram be inserted into the pneumatic squeezer? Square side to outside or inside?
I wanted to cover that. Let's come back to that. What are the other ones? Can we rapid fire through those?
I'm slow building and working on fuselage now after the tail and wing kits. How many of you would rather, this is a question to the group, would rather use a long rivet set, 10 or 12 inch versus the double offset rivet set? Okay, you'd use the long one. And on that subject, how the heck do you use that without tweaking the heck out of the material, since the force is offset from center?
So are we talking about riveting the skin, or are we talking about riveting the ribs to the spar?
Working on the fuselage now. Not clear if it's skins or ribs to spar, Frank says.
Okay, the ribs to spar, the double offset set. Yes. Okay. This is really designed to do the skin to the rib. Yeah. So that you can do the top skins of the wings. Sorry, just kind of brain lock up there. So you can do the top skins of the wings with a larger bucking bar. Trying to figure out how to do this fast. That way you're not pressing with the mushroom set on the outside of the airplane and conforming it to the rib. You're keeping a flat plate on the outside, and you're conforming the rib up to the flatness of the top skin of the wing. So if you do the whole top skin that way, then your whole top skin's flat, and then the bottom where you don't look, you can do the conventional way. But for the rib to the spar, you do want to use that double offset set. Kind of to touch on your question about it not being straight, it's not straight. They are slightly more set on one side than the other. Good question.
I found, okay, there's a question about QA for the short 41 rivets, and it's hard to get exactly square to the skin. This is for Rand's airframe kit. So might want to take this one offline.
We're talking about a pulled rivet.
A pulled rivet, yes, correct.
Okay. Yeah, let's answer that one in a follow-up.
Okay.
Okay, so I'll go back to this question about the squeezer, and I did want to touch on this. That's why I have this squeezer sitting here that's kind of half taken apart. I'll touch on a couple things here because we keep having similar questions on this. So let me clear some stuff out of the way. And this was the pneumatic squeezer question, right? Just to be clear before I carry on.
No, it was more
how to put the adjustable ram in the squeezer.
Yes, yeah,
Okay,
going back
good.
to that one, yes.
All right.
Correct.
All right, so on these pneumatic squeezers, there's one end here is the air inlet swivel connector. This connector you can take out if you need to and disassemble the valve for like cleaning it. That's the only thing you should take apart other than taking the yoke off of the squeezer. So anything else inside of here, there's all kinds of loose needle bearings and all kinds of stuff that is really easy to mess up. I mean, we're all handy, but yeah, that's not one I want to get into. A common question that we'll get is with this safety valve here. So the way this is designed, I guess I need to switch cameras again. The way this is designed is so you have to push up on the trigger and then in to engage this valve. And so occasionally they'll come not adjusted correctly, and you try and just push in and it doesn't work. So you can adjust this Allen screw here to move this lever both up and down and the trigger in and out based on where you clamp this back down at. So this is just the valve here that goes in and out to actuate the squeezer. Sometimes they come adjusted so that, and that's why I have this big uncommonly used yoke on here. Sometimes they'll come so that it hits the yoke. Get my hands out of the way. It hits the yoke here before it will let you engage the valve. And so that's the fix, is to just move this down or up, move it up. So it engages the valve before it hits the yoke. So that's one of the problems that we see with people and their setup of their squeezer. And then the other one, and the answer to this question, is the ram in the squeezer here. So the adjustable ram has a profile like this on the end. And the reason for that, there's a round, I just cannot, everything's backwards. There's a round end and a flat end, and the flat end goes in toward the center. So there's a kind of a cam-shaped lobe there that rides on. And so as that cam comes up, it's pointer. It stays in this little pocket right here. So the flat spot goes toward the center of the squeezer. Now, if you put it in wrong, if you put it in sideways, or if you put it in backwards, because a lot of people will try and line up the flat with the flat of the squeezer body, then the yoke won't go on. The front yoke pin will go in, but the back yoke pin will not. And so when that happens, it probably moved while you were trying to get it lined up. So yep, it goes with the flat toward the center. And then the other thing I wanted to mention is when it's all the way down and you're looking down in here, you'll see a bearing. Right, gosh, everything's backwards. You'll see a bearing right here, right at the end of the screwdriver. Occasionally we've had squeezers that are, for some reason, and I'm not one to get inside of there and see what's going on, but we'll go to the up position and kind of lock there and not go back down. You should be able to reach in there with no air on the tool and articulate this cam back and forth. And like I said, occasionally we've had less than half a dozen in 30 years that have done this, but we've had 2 in the last couple months that have kind of stuck in the up position. So if it's stuck, you can't push it back down and see that bearing. And so then we need to send it in for service. So we've had that happen a couple times.
Awesome. There was one other question related to pneumatic squeezers. It's and also about hand squeezers. There's a note on the pneumatic squeezer that says "do not oil." Is there lubrication needed for I believe the hand squeeze, or it just says for the squeezer?
So there is no lubrication for the pneumatic squeezer. This is actually a leather piston that goes up and down here, and it's lubricated with a permanent heavy grease. And so if you lubricate it through an air tool oil like you normally would an air tool, it just thins out that grease, and then will start leaking around the piston, not developing power, and then you have to send it back to get it, rebuilt, re-greased. So it doesn't ruin the tool, but it ruins your ability to use it. With the hand squeezer, we have some grease ports built into the internal parts. Same kind of deal where we have a special tool that we inject grease after it's all put together, and it shouldn't need any grease from then on. There's some oil impregnated bronze bushings, some brass rollers that run in a slot. All of that's permanently greased. If you get it really, really, really dirty, you might send it back to us and have us redo it, but there's no way to inject grease into those grease passages in the field, so to speak.
Awesome. Great. Thanks, Mike. This was, oh yeah.
One question or one more thought about air tools. So other than the pneumatic squeezer, you want to, in spray guns, but I think that's obvious, you want to use air tool oil in them. And I suggest that after you've had a work session, you put a couple drops of air tool oil in the air inlet of your rivet gun or your drill, plug the air back on, hit the trigger once so it throws that oil all around and displaces any water from your line, unplug it, and then put it away. So all the directions say to oil it before you use it, oil it after you use it.
Awesome. Cool. Well, that's time. Thanks everybody for coming and asking such good questions. And John, especially thanks to you for continuing to keep Mike on his toes and help the good of the group here.
Yeah, thanks for coming, John. And if you guys want to do this more often, let us know in the comments. It just goes fast for me. I feel like we still have questions left to answer. So it's a great time. Appreciate it.
All right. Thanks everybody. Cheers.
Thanks.